Hey everyone, welcome to 5.8 homework. I'm going to start with the practice problems and then I will go back up and do a couple of these as an example. So draw a diagram to show that this is equivalent to this. So because there are 1, 2, 3, 4 terms here and 2 in each, I'm going to make a box that is 2 by 2. So 2x plus 5 times x plus 3 is 2x squared. 5x, 2x times 3 is 6x, and 3 times 5 is 15. So now I have 2x squared. I can combine the 5x and the 6x to make 11x plus 15. And it says match each quadratic expression that is written with a product with an equivalent expression that is expanded. So let's go ahead and write this. X squared plus outer 6x plus inner plus 2x plus 12. So this would be x squared plus 8x plus 12. So that goes with h. 2x squared plus 4x plus 8x plus 16. This is going to be 12x, so 2x squared plus 12x plus 16. That is g. Next we have x squared plus 4x plus 8x plus 8 times 4 is 32. Make sure that you're multiplying here. I noticed some of you tried to add there, and this is multiplication, so be careful with that. So it'll be 12x plus 32 here, so we have e. And then our last one then, 2x squared plus 6x plus 4x plus 12. So that goes nicely with f, and we can confirm that this is 10x. So they match. All right, select all expressions that are equivalent to x squared plus 4x. So if we were to multiply through this, we would get x squared plus 4x. That works. Now here, you all had a little bit of difficulty with this. When the square is on the outside, everything in that parentheses is going to be multiplied times itself. So if you had zxy squared, it's going to be zxy times zxy. Right? If you had an apple in here, then it's an apple times an apple. All right? So anything that you have in the parentheses is going to be multiplied by itself. All right? So this is this, which means that we're going to FOIL it. We'll get x squared plus 2x plus 2x plus 4. Right, because I have to multiply this times this, and then this one times this one. And so this will be x squared plus 4x plus 4. It has this plus 4 here that this one does not have, so this does not work. We know, looking at this here, that we're going to need to multiply x squared plus 4x plus x squared plus 4x. So here we would get 2x squared plus 8x. That is not equivalent. Okay, here we would get this same thing, but then subtracting 4. And so this would be equivalent because we would get x squared plus 4x, and we would subtract the 4. So this one does work. And then lastly, this is written the same as this, except our x is second. This is still going to be x squared plus 4x. So this is also equivalent. Tyler drew a diagram to expand. Explain Tyler's mistake. So here is his diagram, and then we want to figure out what did he do wrong. So I see it immediately. Pause here, see if you can figure out what he did wrong. All right, I'm going to give you a hint now. This one and this one are incorrect. What did he do wrong here? So remember that this is multiplication. And so it should be this times this, which gives us 10x, and this times this, which gives us 15. So again, that was the common mistake I saw made today, too. And so he added, and what's worse is he added unlike terms. He added 2x plus 5. That cannot equal 7x, right? So he added, instead of multiplying, and then again, in particular for the 2x and the 5, he added unlike terms. All right, number 5. Explain why the values of the exponential expression 3 to the power of x will eventually overtake the values of the quadratic expression 10 times x squared. And this is again because exponential expressions will always outgrow because we are repeatedly multiplying by the same factor of, in this case, 3. Number 6, a baseball travels d meters, t seconds after being dropped from the top of a building. The distance can be modeled by this equation. So this is how far it has traveled being dropped. So not how far it is from the ground. Which graph could represent this situation? So again, we're looking for something that is increasing, and we have that here, but then it's A or B. Well, A would be a linear expression, which means be increasing by the same amount each time. It has to be graph B. And we know this because it is exponential, and exponential graphs have a curve. We can also say that if we were to look at just some values here, right, if I plug in 1, notice that works for both of these. But if I plug in 2 as a value, I get 2 squared is 4 times 5 is 20. So 2 comma 20 works here. But if I were to look at the 2 here, this is 2 comma 10. That does not work in this equation. So you can also say you tested points. All right, number 7 says consider a function q defined by q of x equals x squared. Explain why negative values are not included in the range of q. This is because any number times itself will always be positive because a negative times a negative equals a positive, right? So as an example, we had negative 5 squared, right? And this would be the same as negative 5 times negative 5, which is going to be positive 25. So this will always have positive values, and you will see on the graph it will look like that, right? That graph is never going to curve downward. All right, based on past concert, a band, so this is a revenue question, predicts selling this at P dollars. So this is the number of tickets that they can sell, and this is the cost of the ticket. It says complete the table to find out how many concert tickets the band expects to sell. So if the ticket price is $10, they would sell 600 minus 100, they would sell 500 tickets, and that means their revenue would be $5,000. So you're going to complete this table. Again, you're plugging 15 in for P. So that would be 600 minus 150, which would be 450, and then multiplying 450 by 15. All right, 20 times 10 is 200, 600 minus 200 is 400, and then multiply 20. All right, you're multiplying these to get your revenue because the number of tickets times the cost of those tickets will give you how much money you bring in. So you all can complete this table without Miss Lee. So my expectation is that this whole section is done on your own. I will do this last one here, this equation, right? Our number of tickets is represented by this equation, 600 minus 10p. So if we multiply, we'll get 600p minus 10p squared. All right, but the rest of that you should fill in on your own. It says, in this model, at what ticket prices will the band earn no revenue at all? So obviously, if we have $0, then they will not earn money. And then also, if we get to 60, we'll get 600 minus 600, which is 0. So if they are $60, we will also not get any money. And then it says, at what ticket prices should the band sell the tickets if it must earn at least $8,000 in revenue to break even to not lose money on the given concert? Explain how you know. So let's go ahead and take a look at our graph. So let's shift over to our calculator. We're going to do 600x minus, oh, nope, that's wrong. 600x minus, let me just make sure I have this correct here, 10x squared. So 10x squared graph. Okay, that is, let me just make sure I did this correctly. Yep, I did. Okay. So this is very hard to see. So let's go ahead and move our window out. We're going to make our X max on there. I believe 60 was the max that we put. Let's put 60 there. And then our Y min, that's fine. Our Y max is going to be pretty high. Let's try 2000 and just see what we get there. All right, so that's still not tall enough, right? We can still not see the top there. So let's change our window. Let's change it to 100,000. This looks pretty big. Oh, that was too large. Okay, so that helps me narrow it down. I'm gonna do, let's do it by half and see how that looks. That's a lot better. That's close enough. So now we're gonna do second calc, and I want to get my maximum, which is 4. And this would tell me what my best rate would be, right? So I'm gonna estimate it to be this about $9,000. And it says in the question, they need to make at least $8,000. So let's take a look here. And I'm going to press the button trace because that'll keep it on the line here. And I'm going to move it to the left. And I want to see where is it going to be less than $8,000. So $8,000 looks like at about 20. All right, so if we sell the tickets for $20, then we could probably say that. And then we can double check that by putting in 20 times 10 is 200. And then we would have 600 minus 200 is 400. 400 times 20 is 8,000. So this works out for that side. But then I also want to look over on this side over here. And again, we're looking at where it is 8,000. So that looks to be about 40. Yeah, probably about 40 would be good. We can say also here, right, mathematically too, that makes sense because 40 times, or 10, yes, is 400. 600 minus 400 is 200, and then 200 times 40 also gives us 8,000. So at $20 and $40, we would, between $20 and $40, right, because that amount in between as well, we looked at kind of the peak here, you know, selling it at $28, $29, $30 would also be okay. All right, a population of bears decreases exponentially. The population was first measured in 2010. So this is a review of our exponential functions. Our starting amount is here. The annual factor, so it goes from 400 to about 320. So we can find that annual factor by dividing, sorry, let's just a second quit. Let's clear that out. 32, is that right? 320 divided by 400. Okay, and give a factor of 0.8. So 0.8 is our factor that we're multiplying by each time. And we can try that again if we do 320 times 0.8. 320 times 0.8. We get 256. And so that looks about correct, right, for 256 there. But we can see this in our 320 over 400 gives us a factor of 0.8, or 80% is what is left. Using function notation, represent the relationship between the bear population. So we're going to write a function here. So f of t, or b, equals, our starting amount is 400, yes, times 0.8, and it's exponential, so to the power of x, and actually I said f of b, so I should make it to the power of b. Oh, no, it should be, I don't know why I wrote it like that. There we go, t. Oh, because b. So you could say b equals f of t. All right, our last one, equations defining functions a, b, c, d, and f are shown here. Select all the equations that represent exponential functions. So remember, exponential functions are when the exponent is a variable. So a has an exponent, but it's not an exponential function. And you could also write 2 cubed is 8, yes, and that's 8x. This is actually linear. B has an exponent in there, in the, has a variable in the exponent, so that is exponential. Same thing for C. We see that exponent is a variable. This one is actually quadratic because it has a squared term. And then here we also have a exponential function because, again, our exponent is the variable. All right, let's go back real quick to a couple of examples in the classwork. You do need to make sure you complete these. So you're responsible for doing these. So I'm going to show you an example with this one. You can do the box, so 3n plus 2 times n plus 3. The key thing here is you want to make sure you're multiplying, okay, so that you get a adequate answer here. So some of you did 2 times 3 and you put 5. 2 times 3 is 6, make sure you're multiplying. And then you need to combine your like terms, so 3n squared plus 11n plus 6. You can also do FOIL, so you can do your first, outer, inner, last. It's also fine to do it that way. You'll still get the same answer, but I do want you to condense it and combine your like terms. So make sure to do that. Let me show you a quick one with a negative. Let's take a look at this one right here. If we were to do r plus 1, r negative 3. So put that negative with the 3. Remember, the sign in front of the number goes with that number. So r times r is r squared. R times 1 is r. Negative 3r. And then negative 3 times positive 1 is negative 3. Now we can combine our like terms. R squared minus 2r, because negative 3r and positive 1r, minus 2r, and then minus 3. Again, same thing you can do. R times r is r squared. R times negative 3 is negative 3r. 1 times r is positive r. And 1 times negative 3 is negative 3. So you get the same answer here. We'll still get r squared minus 2r minus 3. But you have to be really careful with that sign. So as you're doing some of these negative ones, just be really careful. You'll notice here, you should end up with a positive 2 in there because you're going to have a negative times a negative. I'll show you this one too as well really quickly. So n minus 1, 2n minus 2. Again, that negative sign stays with the number that it is with. Okay, the negative in front of the number is part of that number. So 2n squared minus 2n. N times negative 2 is negative 2n. And negative 2 times negative 1 is positive 2. All right, so now we can combine 2n squared minus 4n and plus 2. Okay. Again, if you were to do FOIL, that's perfectly fine, but you have to make sure that you keep those signs together and you pay close attention to any negative signs. If you need help with any of this homework, feel free to reach out, but I want to make sure that you complete all of these because it's good practice to make sure you know how to do it. Your homework code word for today is peanut. Peanut is your code word for today because we have peanut M&Ms. If you have any questions, let me know and I'll see you tomorrow.